Well, one oracle can perform extensive research on any given topic or questions. You can actually perform indefinite research, but you can limit its cycles. We go by cycles. We can actually run this, and while it's running, we can go over some of the past research, such as the AGI timeline, Python versus JS in the future, and the purpose of the universe. Let's actually run this and see quickly how it's working. And then we can actually review the past research and eventually review the code. Let's ask a financial question. Price prediction for NVIDIA stock price by 2030. Now, this is not a financial advice. I just do want to say that. At the end of the day, this is going to be using Perplexity and a large language model. It's going to generate search terms. I'm going to get answers from that. It's going to form beliefs and assumptions. It's going to update those beliefs and assumptions at every cycle and eventually going to answer it. This is going to go on for 10 cycles. Okay, while this is ongoing, let's take a look at, for example, the AGI timeline. As we can see in the first cycle, it formed some beliefs based on the search that it performed and some assumptions. Beliefs are what it deems to be accurate and correct, and assumptions are what it thinks might be correct. And it actually updates these. For example, in the second cycle, we can compare these two files by compare selected. And as you can see, the first one is on the left and the second one is on the right. It had updated quite a lot in both its beliefs and assumptions. So it goes off of these two variables when eventually answering questions. It also creates interim answers. We can specify about how many cycles we want to summarize and get an interim answer. By the way, before continuing, I do want to mention that the code project files for this is available at my Patreon, along with a lengthy video on how I built it live. You can actually find this down below at the comment section and also in the description. We will be reviewing the code, but at the end of the video, I will put a preview of the course in which I actually built this. It's part of my 1000x masterclass. It's the 24th chapter. So let's take a look at it as far as the research AGI timeline. The first answer was, predicting the exact timeline for achieving artificial intelligence remains uncertain as soon as mid-2020s to decades in the future. And then it goes on to perform 3 more research cycles and then answers again. This is again a bit vague. But as we can see, the final answer was interesting. It said the artificial general intelligence is estimated to be achieved around 2028. So after 10 cycles of research, predicted that AGI is going to arrive at 2028. Of course, you have to take this with a grain of salt, as this is, at the end of the day, is produced by a large language model. Now let's come back to uh, our research that is ongoing about the NVIDIA stock price. I have actually just modified the script before recording this video. Now it actually saves the question and answer pairs as well. So for the first cycle of research, these are the questions that it asked, and these are the answers that it has received from Perplexity. And here is beliefs that it has formed and assumptions. And then the second set of questions and answers, along with the beliefs and updated assumptions. And it has given an interim answer right here. Based on current projections, NVIDIA's stock price in 2030 is estimated to range between 800 and 4,226. And then it goes on to perform further research on this. It creates the questions itself. Each of these questions are actually unique. Regulatory risk affecting NVIDIA stock price, impact of global supply chain, and then the interim answer by the cycle 3 is stock price expected to reach approximately 3,000, and we are still ongoing the research. And if you look at the terminal, we see that when we start a cycle, it generates search terms. Here are the search terms, NVIDIA strategic acquisitions impact. It generates these search terms based on its beliefs and assumptions that it has formed. So it also has access to its previous questions so as to not repeat same questions. For example, NVIDIA EGX platform effect. So it's doing some detailed analysis. Then we perform searches for each and then in parallel, and then get the search results, and then we update the beliefs and assumptions. Once the beliefs and assumptions are updated every 3 cycles, we get an interim answer as specified with this parameter up here, summarize every cycle. So in theory, this can actually run indefinitely if we set max cycles to a really large number, for example. This is very interesting. We are almost at the end of it. We entered cycle 8. If you were to compare, for example, the current state of beliefs and assumptions with the first set of beliefs and assumptions, we can see that the latest is on the left and the first one is on the right. That quite a lot has changed. And even if you were to compare from 8 to 6, 6 being on the left, and eight being on the left and 6 being on the right, even just 2 cycles, it has actually updated its beliefs quite a lot, include also its assumptions. So this is a really interesting process. I'd like to explore this further. And we are almost at the end, by the way. Let's see what answer we get. We're going to get one more interim answer. Actually, we have. Based on current projections, NVIDIA stock price is expected to range between 800 and 4,000. Okay, it went back to it. What was our first answer? It was 804,226. So it switched to 804,000. And we get a final answer. A final answer says NVIDIA stock price is projected to range between 800 and 4,000 by 2030. Again, like this is not financial advice. It also summarizes its beliefs and assumptions at that time. NVIDIA is anticipated to experience significant growth, potentially reaching a stock price and a market capitalization of the 10 trillion, it says. And then here are these assumption summaries. So now let's actually review the code. But before doing that, I would like to mention, if you're enjoying my content, you can always visit my website, echohive.live. You can find the link in the description and watch all my other videos. There's actually currently over 350. I'm supposed to update this website. The auto prompt engineer, AI YouTube search, all one full stack web app builder. You can watch all these videos for free, but if you become a patron, you can also download the code files for each one of them easily. My patrons really do love this. And also my 1000x masterclass. Check this out. My 1000x masterclass is actually a course I've created in which I teach how to build with Cursor. The latest latest chapter of it is this one, how to build an O1 Oracle. It's hour and a half long, filled with great insights. I do highly recommend it. The full course is over 13 hours of content and 24 chapters. Okay, now let's review the code. So we have our imports. As a matter of fact, the requirements for this is just OpenAI and async.io. And we initialize async.io OpenAI client for Perplexity with the base URL. And also we initialize an O1 client with async OpenAI. This, I'm not passing an API key because it auto-detects it from my environment variables. You can change that and pass it any way you like. We initialize the current beliefs, current assumptions, generated questions, and cycle QA. Empty lists. Cycle QA is going to be these. So we can save it as a nice JSON file every cycle. Here we can specify how many questions we would like to ask per cycle, and then we specify max cycles, and then summarize every is going to determine after how many cycles we would like to get an interim answer. So we can see how the thought process affects its beliefs and assumptions. If you like, we can actually run this again while we are actually reviewing the code. Let's actually go ahead and do that. As a matter of fact, let's stop this and change this questions to 8 and max cycles to 20 and ask the same question again. Or Perhaps let's ask a different, more interesting question. Let's actually ask how were the ancient Egyptian pyramids were built exactly. We're looking for methods of building. Let's just send it. It's going to work in the background. We can actually delete this research. Yes, and then we can begin new. I should have actually copied it. Anyway, so while this is ongoing, we can continue reviewing the code. So we have a first async function, generate search terms. It's going to take in user input, beliefs, assumptions, and previous questions. We're going to call O1 Mini with this. We're going to say you're a diligent, thoughtful, critical research AI assistant. Let me zoom in even further. You will be given a user input, a set of current beliefs, and set of current assumptions, which will be empty to start with. It's going to actually form these itself. As you perform search, you will update the beliefs and assumptions. You will then generate this many unique web search terms based on the user input, and most importantly, current beliefs and assumptions to further study the topic. These questions need to be based most importantly on the current beliefs and assumptions. You have to base the question solely on the current beliefs and assumptions to find out more of what you need to learn to answer the user query. And then we pass on the current beliefs, current assumptions, and then previously generated questions. Doing it this way also actually automatically triggers prompt caching. You do want, when you're writing lengthy prompts, you do want to keep stuff that's not going to change. And at some point, the first beliefs are going to be least changed. So in any case, we're hoping for some prompt token savings. Please generate this many new unique web search terms based on the following user input. Ensure that these search terms are different from the previously generated questions, if there are any. Provide your response like this. Then we get our response. Our next function is perform perplexity search. We're going to use Llama 3.1 Sonar Large 128K online. And we're just going to perform this, going to perform search one at a time. And we're going to append the question plus the answer to cycle QA list. Another function is update beliefs and assumptions. So here we are again going to call O1 Mini. Based solely on the search results, update the current beliefs and assumptions. Provide your response as two lists, updated beliefs and updated assumptions. Current beliefs, we pass in, current assumptions, and search results. And then before we ask it to format its response as such, beliefs are going to go like this, as many as is needed, and so will the assumptions. However, beliefs are defined as these are what you have so far found out to be true. Feel free to update them as you learn more. And assumptions are these are what you think might be true. Feel free to update them as you learn more. And we get our uh, beliefs and assumptions and save them to the lists appropriate. Update the list. Save beliefs and assumptions. We create a research folder if it doesn't exist. And we properly name the file. And then we create a dictionary and then save it. Get final answer is going to take in a user input. Again, obviously going to call O1 Mini. And based on the beliefs and assumptions formed during the research, provide a final, concise, and exact answer to the user query. Do not give vague answers. Provide a direct response based on the beliefs and assumptions formed during the research. Also provide a summary of the latest beliefs and assumptions. We pass in the user query, current beliefs, current assumptions, and we ask it to format it like this as the final answer, belief summary and assumption summary. Then we update everything. And we have a same final answer function, which is just going to write everything to its appropriate place. Now we have this get interim answer, which is going to trigger every so often as specified by this parameter up here. This says, based on the current beliefs and assumptions, provide an exact interim answer. This is pretty much the same, except instead of being a final answer, it's an interim answer and summary of the assumptions and beliefs. And then we have a function to save the interim function. Save cycle QA, just a helper function to save the cycle QA session. Research cycle. Okay, here is our global variables, current beliefs, current assumptions, generated questions, and cycle QA. So for each cycle, we reset the cycle QA for each new cycle. We generate search terms, call in this function, extend this, add new questions to list. We generate the search term, enumerate and print them. And then we create a search tasks list. And then we call async.gather to get the results. And then we are actually printing the first 100 characters of each result. You can comment this out if you like. Then we call update beliefs and assumptions. We're not printing those, so it's more concise here. And then we every summarize cycle we call get interim answer. This is going to provide us with interim answer, belief summary, and assumption summary. And then we save that answer. After all cycles are complete, get and save the final answer. And we just take in user input and then start the user research cycle. So this is it. There's also a QA, README that I provided with. This is also in the Patreon download. Like I said, this project is at my Patreon. Link is in the description if you want to download it. It's accompanied by a video in which I actually built this from scratch. Actually, I built it in steps. There's the basic Oracle, there's the advanced Oracle, and then there's the older Oracle. I call it long range. I should actually call this version 1 because I'd like to work more on this. So remember, we had asked the Oracle on how the pyramids, ancient Egyptian pyramids, were built. For our first question, for example, it came up with material sourcing for the Great Pyramid, tools used in pyramid building, astronomical alignment. So it's asking quite a lot of questions, and it's actually forming beliefs and updating. Let's take a look at the first interim answer. It says the ancient Egyptian pyramids were constructed using a combination of advanced engineering techniques and organized labor, primarily using locally sourced limestone and transported granite from Aswan. The Egyptians shaped these stones with copper and arsenical copper tools, employing dolerite pounding and sand abrasion. So you can read the rest of it. Here I'll browse. Let's read the little portion of the belief summary. The current beliefs indicate that the pyramids were built using primarily limestone and granite. Let's take a look at the interim answer, as we know that these answers can change. The ancient Egyptians were constructed using, it hasn't changed much here, but there's actually more information. Workers queried and precisely cut the stones, achieving joint gaps as narrow as 0.5 millimeter. Let's compare these answers, see if it has changed drastically. Apparently it had. Let's compare this 06 answer to interim answer 09, and it is still ongoing. So this has also changed. So let's take a look at the latest interim answer. The ancient Egyptian pyramids were constructed through a highly organized and sophisticated process that involved several key methods: material quarrying and shaping, transportation of stones. Massive stone blocks were transported to the construction site using sleds lubricated with water or fat to reduce friction. These sleds moved over prepared paths, including wet sand, interesting foundation preparation, construction ramps and block placement, precision assembly, workforce organization and management, final finishing. It is still ongoing, but we are reaching to the end of our video. But we'll wait for one more interim answer, and then we'll end it right there. From my quick rough estimation, each 10, let's say 10 cycle with 5 questions cost about maybe 50 to 70 cents in OpenAI usage. And I'm not 100% sure on the Perplexity, but maybe another 20, 30 cents on Perplexity. So each 10 cycle costs about $1, perhaps. But you get quite a lot of information out of it. So if you wanted to research a topic, this is pretty remarkable. Okay, so we're waiting for the next interim answer and then we'll end this. Okay, we got our interim answer. Ancient Egyptian pyramids were constructed through a highly organized, sophisticated process. So here it explains further. Let's compare how much it changed from the previous interim answer to here. So quite a lot. So this process works. It's pretty effective, and we can see that like the question and answers, questions that were produced are different for each iteration and became more sophisticated over time. Archaeological evidence of tool wear in pyramid workers, temporary water channels, pyramid foundation leveling, role of religious ceremonies, influence of Nile flooding, abrasive compound stone cutting techniques in ancient Egypt, climate impact, logistical organization, storm transportation, pyramid projects. Let's take a look at the answer real quick. The logistical organization, storm transportation for pyramid project in ancient Egypt were highly complex. Very nice. Comparative pyramid construction techniques across dynasties. Yeah, so that's 8 questions for one cycle. Okay, so this is it. Thank you very much for watching. Like I said, do check out my 1000x masterclass. There's quite a lot there. You can watch the first video for free, preview each chapter for 2 minutes. Also, you can find all my videos at my website. And if you're a patron, you can download project source code for them easily. And I also have consulting tiers at my Patreon. Take a look at those as well if you're interested in getting in touch with me one on one or if you need help with your projects. Thank you very much and take care. Hey, everybody. So we're going to try to do an experiment and create a O1 oracle. What I call is an O1 oracle, which is going to perform long range, long term research and studies. Let's see how this works. I'm thinking we'll start with perplexity, but as an option, we'll also use Exa's API to perform search, perhaps. We can give that a try, or even archive papers using archive library. So we're going to experiment and see what works. So here I have a sample perplexity call. Actually, let me rename this to sample perplexity. You may just use that because it will be the easiest to get started with. And let's create the O1 Oracle file. O1 Oracle.py. And then let's go to OpenAI's docs and grab the O1 code. Docs, we don't need the API reference. Okay, let's go to reasoning, and copy this code. It's going to be our backbone. So we're going to use mini. So let's begin. So obviously we want to take a user input and then we want to perform extensive research on it. How can we do that? I've done this before. Let's begin with that. Should be pretty quick. Let's actually import async OpenAI so we can make async calls. Okay, my environment API key is being auto-detected from environment variables. So let's open the chat. Actually, let's begin with Control K. Taken user question and allow O1 mini to generate 20 distinct questions exploring different aspects of the question to perform web search with. Okay, let's just begin with this, and then we'll adjust it. Okay, you're an AI assistant tasked with generating 20 distinct questions exploring different aspects. Questions will be used for web searches. All right, let's do a follow-up. Instruct the model to return questions between questions tag. So we can easily parse it. Here we go. Also, we want to take user input. Actually, we can handle that later. Hard-coded question is fine for now. Okay, so we're going to print the questions. Let's first make sure this part is working all right. Well, system message is not supported with O1. We just will change this to user. It's good to test it iteratively. Max tokens is also not supported. So we're going to have to remove that. So this should give us 20 questions. Okay, good. Right on. We get our questions. That's good. So now we're going to make a call to Perplexity. Let's copy the sample code. So let's do Control L. Chat should be easier with this. After, oh, new chat. Add that in there. Let me copy this. After receiving the questions, let's make a call to Perplexity in parallel using async OpenAI, and then combine the answers into a single context and write it to file. Then use this to make another call to O1 Mini to get a final answer. Oh, did I paste? Oh, it already knows. Good. Yeah, it kept. So I think I forgot to paste the code, but it already knew it somehow. That should be good. Let's apply this and accept. It's going to generate questions. Then we are going to call it with async IO, gather those using the following context, answer the question. Okay, we don't want question to be that, but we can ask what is the most proven life extension method. And we are writing the search results. Oh, we are also including the question within the context. Let's not do that because I've done this before. And if it keeps the questions within the context and we are also sending this one last question, it can get confused. So it is, let's modify it. Let's fix that. It's good that we are saving the Q and saving the Q and A pairs. But for context, for O1, let's not include the questions. So this is just a start. Context for O1, join answers. Okay. Yeah, we're going to save it with question and answers, but we are going to only send the answers. What is the most proven life extension method? So let's try this. This is exciting. Hope you're all having a great evening. It's evening time for me in West Coast. Hope you're having a lovely weekend. Let's close this. So now we're getting answers. Generate questions, search perplexity. You could have done a print searching for a question. Yeah, okay, so this happens when we are saving files. We do want to use encoding UTF-8. That's fine. Now we actually added this print statement. Let's use term colors for colorful printing. Let's do that in green so we can see. Okay, we made all the calls. Oh, system again, it added system. Wait, what happened? Unsupported value role does not support system. Oh, that's right. It added a system message here, user. Let's say you are a thoughtful and critical research AI assistant, let's say. Yeah, let's try this again. So we are using both OpenAI and Perplexity APIs, and we are getting these answers in parallel. That's why it's happening quite fast. So its questions are quite diverse. What scientific studies support effectiveness? How do dietary interventions? What role does regular physical exercise? Here is the answer. Search results. So we get Q&As here. And then, oh, we didn't say the final answer. Yeah, conclusion. Caloric restriction stands out as the most proven life extension method through this extensive validation. So this is the first, let's say, let's call this O1 Oracle Basic. Let's also save we also want to save the final answer to file. Save the final answer to file. Maybe we'll build this into a web app too. Oh, oh, here, apply. Okay, now it's going to say the final answer, which we don't have to test. It's going to happen instead of just printing. It's going to save, but it's also it gives a quite a thoughtful answer here. Final answer based on the comprehensive scientific evidence provided. Caloric restriction emerges as the most proven method. So this is nice. Now let's move on to how we can actually make this even better. Okay, let's go now. Let's say let's copy this. Say O1 Oracle Advanced .py, and then now let's also enumerate these. Let's put one in the beginning so we can see the progression. One, and this shall be two. Oh, rename. So one way to extend this is actually to come up with first like general topics to discuss. General general yeah, topics around the question, and then generate questions within those topics, right? We can do that. So let's do Control L. Let's add another O1 mini call before question generation. This call will be generating topics of research related to the question first, and then we will okay, how many topics? Let's do 10 topics and 5 questions each. 10 topics. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses, and my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well.